Hello there, and welcome to the Sleepy Science Channel. Tonight, we are diving into the world of whales, the ocean's largest and most extraordinary mammals. They are bigger than dinosaurs, older than human cities, and more complex than almost anything else alive today. Whales breathe air like we do, yet spend their lives in a world of pressure, cold, sound, and secrets. Their hearts are the size of small vehicles. Their voices ripple across oceans. Their memories stretch across generations. Some live for more than 2 centuries. Others dive deeper than any submarine. They sing. They strategize. They care for their young with tenderness. They alter the chemistry of the sea with each breath. Whales are not just animals. They are worlds within one. And while we used to hunt them, now we study them, listen to them, and follow them across thousands of miles of open water, still unsure of all the things they know. If you enjoy these quiet journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. For now, just breathe. Let the noise of the day fall away, and let your mind drift into the calm of the ocean. Let's begin. Whales are descended from 4-legged land mammals. Long before whales swam through the oceans, their ancestors lived on land. These early mammals walked on 4 legs, had fur, and spent their lives near rivers and coastlines. They probably looked a little like a modern-day tapir or small deer. Over millions of years, some of these animals adapted to life in the water. Their legs slowly became flippers, their bodies stretched out, and their noses moved higher up the skull to form blowholes. Scientists have confirmed this by finding fossils of whale ancestors with both hooves and webbed feet. Even today, whales still carry tiny remnants of their land-based past inside their bodies. Most species have small, hidden lid bones buried deep within their muscles, serving no purpose now but standing as a clue to their evolutionary journey. When whales swim today, they are completing a story that began not in the sea, but on land. The largest animal to ever live is alive right now. Earth has hosted many enormous creatures, including long-necked dinosaurs and giant marine reptiles, but none were as massive as the blue whale. This living giant can grow longer than 3 school buses lined end to end and weigh more than 300,000 pounds. That is heavier than even the largest dinosaur scientists have ever discovered. The only reason it can get this big is because it lives in water, where buoyancy supports its huge weight. Every day during feeding season, a blue whale can eat nearly 4 tons of tiny shrimp-like animals called krill. That constant supply of energy fuels an animal so large that its heartbeat can be heard from more than 2 miles away. The fact that the biggest animal in history is not a creature of the past, but one that still swims the oceans today, is one of the most astonishing things about nature. A blue whale's heart is the size of a small car. Deep inside a blue whale's chest beats an organ bigger than a person, wider than a dinner table, and weighing more than a piano. Its heart can be as heavy as a compact car, and its arteries are large enough for a small child to crawl through. This enormous heart pumps oxygen-rich blood through the whale's body with slow but powerful beats, sometimes only once every 10 seconds. When a whale dives deep underwater, the heart slows down even more to conserve oxygen. The whale's blood also carries a higher level of oxygen than most mammals, which is important for long dives in deep, cold waters where no sunlight reaches. The heart of a blue whale has to work efficiently to keep such a massive animal alive, especially when the whale is swimming, feeding, or diving to depths no human could survive without special equipment. Whales sing, and we still do not fully understand why. Humpback whales and other species create long, haunting songs that echo through the ocean for miles. These songs are made up of repeating patterns of chirps, squeaks, wails, and low moans. Only the males sing these long, complex songs, and each population has its own unique version. What makes this even more mysterious is that these songs change over time. A melody used one year might slowly shift and become a completely new song a year or two later. Scientists believe the singing might be related to courtship, territory, or communication between whales over long distances, but no one knows for certain. We do know that whales learn these songs from one another, and in some cases a popular new song can spread across entire ocean regions, almost like a hit record moving up the music charts. It is one of the most incredible forms of animal culture ever discovered. A whale's voice can travel across an entire ocean basin. Whales produce some of the loudest sounds of any animal on Earth, and water is an excellent conductor of sound. In certain deep parts of the ocean, sound waves can travel thousands of miles without losing much energy. This means that a whale singing off the coast of Africa might be heard by another whale near the waters of South America. Low-frequency sounds travel the farthest, and many whale species have evolved to communicate using these deep, powerful tones. This long-distance communication makes sense when you consider that whales often live far apart and travel across enormous areas of open ocean. Their voices may help them communicate about feeding grounds, migration paths, or even potential mates. Humans cannot hear most of these deep sounds without special equipment, but they are happening all the time below the surface, forming an invisible web of communication across the sea. Some whales can hold their breath for more than 2 hours. Most humans can only hold their breath for a minute or two, even with practice. But certain whales can stay underwater for more than 2 full hours without coming up for air. Species like the Cuvier's beaked whale and the sperm whale have evolved bodies that are incredibly good at storing oxygen. Their blood and muscles contain special proteins that hold extra oxygen, and their heart rate can slow down dramatically during a dive to make that oxygen last longer. When a whale dives, it also limits blood flow to organs that do not need oxygen as urgently, like its skin and limbs, and sends more oxygen to the heart and brain. This allows it to survive in the freezing darkness of the deep sea, where it hunts for squid or fish. When the whale finally returns to the surface, it exhales a huge blast of air and then quickly refills its lungs. The deepest diving whale reaches depths beyond what submarines can handle. The Cuvier's beaked whale holds the record for the deepest dive of any mammal ever recorded. One individual was tracked diving more than 10,000 feet below the surface, deeper than many military submarines can safely travel. At that depth, the pressure is great enough to crush unprotected human lungs and bones. But whales have evolved a way to survive that pressure. Their rib cages can fold, their lungs collapse safely, and their blood and tissues are built to withstand the crushing force. They shut down parts of their body to save oxygen and use sound to find their prey in the total darkness. These deep dives are not rare. They are part of the whale's lifestyle, especially as they hunt for squid thousands of feet down. The ability to reach places where light never shines makes these whales some of the most extreme animals on the planet. Sperm whales sleep vertically in the water. Instead of lying down like humans or floating horizontally like most fish, sperm whales sleep while standing upright in the water. Groups of them can be found suspended in silence, bodies perfectly still, heads tilted slightly upward, and tails hanging below. They stay like this for short periods, usually no more than 20 minutes at a time, before waking to breathe or dive again. Scientists think this unusual sleep posture may help them stay alert for predators or other dangers, since their blowholes are positioned upward and close to the surface. It also means they do not have to lie flat in the water, which could make them more vulnerable. This strange way of sleeping was only discovered in recent years, after rare underwater footage showed a group of sperm whales motionless and upright, resting together like a forest of living pillars beneath the waves. Whales use bubble nets to hunt like a team of underwater architects. Humpback whales sometimes work together in a highly organized way to catch fish. One whale will swim in a spiral and blow bubbles underwater, creating a rising cylinder of air that traps a school of fish inside. Other whales will swim beneath this bubble net and produce loud, sudden sounds to scare the fish toward the surface. Once the fish are crowded into a tight cluster, the whales burst upward with their enormous mouths open, swallowing hundreds of fish in one strike. This behavior requires planning, timing, and cooperation. It is not instinct alone. Young whales must learn this technique by watching older whales perform it. The bubble net lasts only a few seconds before disappearing, but during that time it acts like an invisible fishing net made out of air, built and used by some of the smartest animals in the ocean. Humpback whales may save other animals from killer whales. There have been many documented cases of humpback whales rushing toward attacks made by killer whales, even when the animal being hunted is not another humpback. They have been seen defending seals, grey whale calves, and even sunfish by putting their huge bodies in the way, splashing their fins, or making loud noises to confuse the attackers. Scientists do not yet know why humpbacks do this. It might be an instinct to protect their own young that sometimes extends to other species. It might also be a form of mobbing behavior used to discourage killer whales from hunting in the area. Whatever the reason, this protective behavior is not rare, and it seems to happen almost anywhere humpbacks and killer whales overlap. These encounters reveal a level of awareness and decision-making that is still being studied, reminding us how much more there is to learn about whale behavior and intelligence. Whales change the long-term chemistry of the ocean with their movements. Whales do not just live in the ocean, they help regulate its chemistry. When whales dive deep to feed and then return to the surface to breathe and release waste, they transport nutrients upward from the dark depths where sunlight does not reach. Their fecal plumes are rich in nitrogen and iron, two elements that are vital for the growth of microscopic organisms called phytoplankton. These tiny plants form the base of the ocean's food chain and produce a significant portion of the oxygen in Earth's atmosphere. When whale populations were much larger before commercial whaling, they played an even greater role in fertilizing the surface waters and boosting plankton levels. Scientists now believe that restoring whale populations could help combat climate change, because more plankton means more carbon dioxide being pulled out of the air and stored in the ocean. Whales are more than ocean giants, they are ecosystem engineers. Whale falls create entire ecosystems on the ocean floor. When a whale dies, its body does not drift aimlessly forever. Sometimes it sinks to the seafloor, and when it does, it becomes the foundation for a bustling deep-sea habitat that can last for decades. A single whale carcass can support more than 100 species of worms, fish, bacteria, and crustaceans. The process happens in stages. First, scavengers like hagfish and sharks tear away the soft tissue. Then smaller animals move in to feed on scraps and leftover fat. Finally, specialized bacteria break down the whale's bones, releasing energy and nutrients that are almost never found in the deep sea. Some of the creatures that live on whale falls have never been found anywhere else, which means entire species evolved to depend on this rare source of food. A whale fall is not just the end of one life. It is the beginning of a new community in a world where resources are scarce. Whales can live for more than 200 years. Few animals on Earth live longer than whales. Certain species, such as the bowhead whale, can survive for more than 2 full centuries. That means a whale alive today might have been born when steam engines were being invented, or before the American Civil War. Scientists know this from studying pieces of harpoons found in old bowhead whales and from examining changes in the amino acids inside their eyes, which act almost like biological clocks. These incredibly long lives raise questions about how whales avoid diseases like cancer or heart failure over such a long period. Their cells divide more slowly, and their bodies operate at cooler temperatures, which may protect them from the damage that comes with age. The ability to live for centuries also allows bowheads to pass down knowledge across many generations, which may explain how they remember migration patterns and feeding areas that span the Arctic. Bowhead whales have the longest lifespan of any mammal. The bowhead whale holds the record for the longest known mammal lifespan, often reaching ages of 150 to over 200 years. These whales inhabit some of the coldest waters on Earth, near the Arctic Circle, where life moves at a slower pace. Their long lifespan may be partly due to their slow metabolism, thick blubber, and ability to stay warm and protected from predators. They even have unique genetic adaptations that help repair DNA damage and resist diseases often associated with aging. Some bowhead whales have been caught with stone and metal harpoons in their bodies from the 1800s, proving they survived encounters with whaling ships more than a century ago. Their incredible longevity makes them one of the most valuable species for studying how to slow aging and increase health in other mammals, including humans, since they show very little decline in fertility or energy even at older ages. Some whales can remember past feeding grounds for more than a century. There are cases of whales returning to feeding grounds that have been unused for decades or even more than 100 years. Scientists have observed that when whale populations begin to recover after being hunted, they often migrate back to areas their ancestors once used, even if no living whale has visited that spot in generations. This suggests an ability to store information across centuries, either through inherited instinct or cultural memory passed from mother to calf over many lifetimes. Whales do not migrate randomly. They follow ancient routes that once led their ancestors to areas rich in food like fish or krill. Even after long absences caused by whaling or environmental changes, they still find their way back. This ability highlights how deeply whales are connected to their environment and how migration is not just an instinct, but possibly a form of memory shared across time. The oldest known whale was still reproducing at 130 years old. One bowhead whale was estimated to be at least 130 years old when it was discovered with a recently formed pregnancy. This is remarkable because most mammals stop reproducing long before reaching a century of life. Humans, elephants, and many other animals experience menopause or lose fertility with age, but this whale was still able to bear calves more than a century after it was born. Scientists believe this may be due to special adaptations in the whale's DNA that protect cells and maintain healthy reproductive tissues over long periods. The fact that whales can continue having young even in extreme old age helps their populations survive in environments where births are rare and calves take years to grow. It also raises questions about whether longevity and fertility are linked in ways that could teach us about aging and health in other species, including ourselves. Whales have traveled the same ancient migration routes for millions of years. Some whale species migrate thousands of miles between feeding grounds and breeding areas every single year, and they follow the same general routes their ancestors used millions of years ago. The ocean does not have visible roads or landmarks, yet whales seem to know exactly where to go. Their migrations can stretch across entire ocean basins, from the Arctic to the equator, guided perhaps by stars, water temperature, ocean currents, or even Earth's magnetic field. Fossil evidence shows that prehistoric whales found in rocks from ancient coastlines were in the same areas modern whales still visit today. Even when human activity, climate change, or hunting reduces their numbers, whales continue to follow these paths, as though the roots are imprinted somewhere inside them. Migration is not just a journey for whales, it is part of their identity, connecting them to their distant past in a living thread of navigation. Humpback whale songs evolve like pop music hits. Every year, humpback whale songs change slightly, and over time, they can become entirely different from what they were before. All the males in a region usually sing the same basic song, but new phrases or rhythms slowly spread through the population, almost like the way a popular tune moves through human culture. When a new song becomes dominant, whales across wide areas start using it, replacing the old version almost completely. Scientists have observed a song created near Australia spreading across the South Pacific over several years, picked up by whale groups thousands of miles apart. No other animal is known to change its vocal behavior so rapidly and culturally. These shifting songs suggest that whales learn from one another and value novelty or social connection, not just instinct. Their music is alive, constantly growing and transforming, just like human art. A blue whale's tongue can weigh as much as an elephant. It is hard to imagine a tongue that weighs more than a full-grown elephant, but that is the reality for a blue whale. Their tongues can weigh over 6,000 pounds and stretch several feet long. The tongue is not just for tasting. It acts like a massive piston that helps push water out of the whale's mouth after it takes in a giant gulp of krill-filled seawater. The whale then uses baleen plates to strain out the tiny crustaceans, swallowing thousands in a single mouthful. Their tongues are so large and strong that a human could stand on one without touching the mouth's sides. This incredible size is needed to process the enormous amount of food required for such a large animal to survive. Even young blue whales consume hundreds of gallons of milk each day, and that massive tongue helps guide the liquid into their growing bodies. Whales communicate in accents unique to their region. Just like humans speak in different accents depending on where they live, many whale species use vocal patterns that are distinct to their region or family group. Orcas in the North Pacific have different calls than orcas in the North Atlantic, and even within the same ocean, separate pods have unique dialects. These variations help whales identify each other and form long-lasting social bonds. Young whales learn the sounds of their group by listening and practicing, much like children learning to speak. These vocal traditions can last for decades and are passed down through generations. Scientists use these accents to track whale movements and family relationships, revealing that sound is a key part of how whales build identity and community. This regional communication is not just noise. It is a form of culture, showing that whales share information and emotional connection through their voices in ways that are still being studied. Some whales have been found with harpoons from the 1800s. In the cold waters around Alaska and Greenland, scientists have discovered bowhead whales with fragments of antique harpoons still embedded in their bodies, dating back to the late 1800s. These harpoons are made from brass and stone and match the weapons used by whalers more than 130 years ago. The whales not only survived the attack, they continued living and growing for decades or even centuries afterward. This astonishing discovery confirms that some individuals alive today were already mature when those harpoons were fired. It also provides dramatic evidence of the incredible toughness of whale tissues and immune systems, which are able to heal around foreign objects without causing fatal infection or organ failure. These survivors are living witnesses of the age of whaling ships, steam engines, and early explorers, reminding us that whales are not just enormous, but nearly unmatched in resilience and longevity. Narwhals have a single tooth that grows into a spiral tusk. Narwhals are sometimes called the unicorns of the sea because of the long, spiral tusk that grows from the heads of males. What looks like a horn is actually a single enlarged tooth that can grow more than 9 feet long. It twists in a perfect spiral pattern and is filled with thousands of nerve endings, making it one of the most sensitive biological structures ever found. Narwhals use this tusk to sense changes in water temperature, pressure, and even the saltiness of seawater. Recent observations also show that narwhals sometimes use the tusk to tap or stun fish near the surface before eating them. Only males usually grow the tusk, which suggests it may play a role in competition or display, similar to a peacock's feathers. Yet, its primary purpose appears to be sensory, not combat. The narwhal tusk is a living window into the hidden world of Arctic waters. Bowhead whales can crack through more than 1 foot of sea ice with their heads. Bowhead whales spend their lives in Arctic waters, where the sea is often covered in thick ice sheets. In order to breathe, they sometimes break through ice more than 1 foot thick using the top of their skull, which is reinforced and shaped like a battering ram. Their heads can weigh several tons, and their neck muscles are strong enough to lift the massive weight and smash upward. This ability allows them to survive in a region where air can be trapped beneath frozen layers for months at a time. Bowheads also use their sensitive hearing to locate thin spots in the ice or cracks formed by shifting currents. Their skill at navigating and surviving in this frozen world is so advanced that no other whale species can permanently inhabit the same waters without the risk of suffocation. These ice-breaking surfacings are a signature of life at the top of the world. Orcas are actually the largest dolphins. Even though they are commonly called killer whales, orcas are not whales at all. They belong to the dolphin family, making them the largest species of dolphin on Earth. Their sleek, black and white bodies and high intelligence are traits shared with smaller dolphins, but scaled up and adapted for life as top predators in almost every ocean environment. Orcas can hunt in coordinated groups, using strategies that depend on the type of prey they are targeting. They may chase fish into tight bait balls, flip seals off ice floes, or create waves to wash penguins into the water. Different orca populations around the world have completely different diets, languages, and hunting traditions, showing a level of cultural diversity rarely seen in animals. Their powerful jaws and sharp teeth make them capable of taking down even large whales, proving that being a dolphin does not mean being gentle or small. Whales sleep half their brain at a time. Unlike humans, whales cannot breathe automatically while asleep, so they have evolved a remarkable form of rest called unihemispheric sleep. In this state, one half of the brain remains active enough to control breathing and watch for danger, while the other half gets the deep rest it needs. Whales may float near the surface or swim slowly while sleeping in this partial, alternating cycle. This is why they never lose consciousness completely the way humans do. Every minute or two, the awake half of the brain sends a signal to surface and take in air. After a while, the sides switch roles so both halves can eventually rest. This sleeping method also helps mother whales protect their calves and allows whales to stay alert in the open ocean where predators or threats may be nearby. It is one of the most extraordinary examples of how brain evolution adapts to extreme environments. Whales can see with sound using sophisticated echolocation. Toothed whales like sperm whales, dolphins, and orcas use echolocation, a biological sonar system that allows them to create a mental map of their surroundings using sound. They emit high-frequency clicks and listen for the echoes that bounce back from objects in the water. These echoes carry information about size, shape, distance, and even the texture of what is nearby. A whale can detect a fish the size of a hand in total darkness, or track a moving object through murky waters where vision is useless. They can also adjust the pitch and volume of their clicks to focus on different targets, similar to how a person might narrow a flashlight beam. Echolocation is so detailed that some scientists think whales may be able to see inside other animals, detecting air pockets in lungs or organs. It turns the ocean into a three-dimensional soundscape where nothing is truly hidden. Sperm whales have the largest brain of any animal on Earth. A sperm whale's brain can weigh more than 20 pounds, which is 5 times heavier than the average human brain. This massive organ controls a complex social life, a sophisticated echolocation system, and a body that can dive more than a mile deep. The brain is housed in a skull filled with a special oily substance called spermaceti, which may help with sound production, buoyancy, or focusing echolocation clicks. Sperm whales live in tight family groups led by older females, and they use a form of communication made up of patterned clicks known as codas. These codas vary between whale clans and may act like cultural signatures. Despite their enormous brains, sperm whales do not rely on vision much, since most of their hunting happens in pitch-black waters where sunlight cannot reach. Their intelligence is adapted to a world of sound, depth, and complex social structure. Blue whales can weigh more than 300,000 pounds. A fully grown blue whale can weigh as much as 30 adult African elephants combined. No other creature in Earth's history has been confirmed to reach this level of mass. Their enormous size is supported by their aquatic lifestyle, where buoyancy limits the strain on bones and muscles. A blue whale eats tiny crustaceans called krill, swallowing several tons in a single day during the feeding season. This energy is stored as thick layers of blubber that help insulate the whale from freezing waters. Their bodies contain massive blood vessels and organs scaled up to match their weight, including a heart that pumps more than 1,000 gallons of blood with each beat. Their weight is not constant either. Seasonal migrations and food availability cause them to gain and lose thousands of pounds throughout the year. Their existence is a triumph of evolution in a habitat without limits on size. Whale songs can form global cultural waves across populations. In certain species like humpback whales, songs do not stay the same from year to year. They evolve and spread through ocean regions in a pattern that resembles cultural change in humans. One group of males may introduce a new phrase or rhythm into its song. Other males hear it, copy it, and over time, the entire population switches to the new version. In rare cases, a song created in one part of the world can spread thousands of miles away over several years, carried by migrating whales and learned like a shared language. These songs are long, structured, and follow patterns of verse and chorus, but we still do not know their full purpose. This cultural exchange shows that whales are not just biological organisms. They participate in a living tradition of sound passed from one generation to the next across the open ocean. Beluga whales can mimic human speech. Beluga whales are known for their wide range of vocalizations, earning them the nickname canaries of the sea. But researchers were surprised to discover that belugas can also imitate human-like sounds. One captive beluga was recorded making noises that resembled distant conversation, complete with rhythm and varying pitch. At one point, it even seemed to mimic the sound of a diver's voice underwater, confusing nearby humans who thought someone was speaking through a radio. Belugas have unusually flexible facial muscles and lips, which allow them to shape sounds in ways most whales cannot. They also lack vocal cords, producing sound through their nasal passages instead. Their ability to copy unfamiliar noises suggests a high level of auditory learning, similar to parrots or dolphins. This skill may help belugas communicate more effectively in complex social groups or adapt their calls to different environments. Whales were once hunted so aggressively that species nearly disappeared. In the 18th, 19th, and early 20th centuries, whales were hunted for their oil, bones, meat, and baleen, with industrial whaling fleets operating across every major ocean. Whale oil was used to light lamps, lubricate machinery, and make candles and soap. Baleen was used to stiffen corsets, umbrellas, and even early car parts. This intense exploitation drove many species to the brink of extinction. Blue whales, which once numbered in the hundreds of thousands, were reduced to fewer than 5,000 individuals. Right whales, named because they were considered the right whales to kill, were hunted so heavily that some populations vanished entirely. Sperm whales became targets for their spermaceti oil, which burns with a clear flame and was highly valued in the lighting industry. It was not until the 1960s and 1970s that global conservation efforts finally led to bans on commercial whaling. Today, many whale species are still recovering from nearly 2 centuries of non-stop hunting. Some whale populations are recovering faster than expected. After the global ban on commercial whaling, many species were thought to need centuries to rebuild their numbers. But recent surveys have shown surprisingly rapid growth in some populations. Humpback whales, which were once reduced to less than 10% of their original numbers, have rebounded in areas like the South Atlantic and the Pacific, with some populations growing at rates of more than 10% per year. Certain blue whale groups off the coast of California now seem to be close to their historical numbers, and bowhead whales in the Arctic are showing steady recovery as well. The rebound is due not only to the ban on whaling, but also to better protection of breeding grounds, reduced pollution, and international cooperation through the International Whaling Commission. While not all species are recovering at the same pace, these success stories show that large marine animals can bounce back when given time, protection, and a healthy habitat. Whales have belly buttons because they are mammals. Like all mammals, whales give birth to live young, and that means every whale begins life connected to its mother by an umbilical cord. When the baby whale is born, the cord breaks, leaving behind a belly button. In whales, the belly button is not a small circular mark like it is in humans. It is a long, narrow scar located on the underside of the body, usually near the middle of the abdomen. This scar is more visible in newborns and fades over time as the whale grows and its skin thickens. The presence of a belly button is just one of many clues proving that whales are mammals, not fish. They breathe air, nurse their young with milk, and maintain a constant body temperature. Even though whales look very different from land mammals, their reproductive system reveals the ancient ancestry they share with every other mammal on Earth. Baby whales double their weight in just a few months on milk alone. Newborn whales are among the fastest-growing animals on the planet. A baby blue whale, for example, can gain more than 200 pounds every single day during its first months of life. This growth comes from drinking enormous amounts of milk from its mother, sometimes more than 30 gallons in one day. Whale milk is extremely rich in fat and calories, helping the calf build a thick layer of blubber that protects it from cold ocean temperatures. The milk has a thick, toothpaste-like consistency, which makes it easier for the calf to drink underwater without it dispersing in the sea. The mother must eat vast amounts of food to produce such rich milk. During this time, young whales stay close to their mothers for safety and guidance, learning how to swim, breathe, and eventually feed on their own. By the time they are weaned, they can weigh more than 15,000 pounds. Whale milk is nearly 50% fat. Unlike the thin, watery milk produced by humans or cows, whale milk resembles a thick cream and contains nearly 50% fat. This high-fat content is essential for young whales, which must build a protective layer of blubber and fuel rapid growth within a short time. In the frigid waters where many whales live, that insulation can mean the difference between life and death. The thick texture also helps the milk stay in the calf's mouth instead of dissolving into the surrounding seawater. Mothers produce this energy-rich milk for months, sometimes almost a year, depending on the species. Producing such dense milk requires enormous energy, so nursing mothers must consume large amounts of fish, krill or plankton-rich water. The fat in whale milk is made of powerful lipids that help the calf grow strong bones, muscles, and organs before it ever eats solid food. This nutrient-rich milk is one of the most remarkable adaptations in the animal kingdom. Whales have hair, just not where you would expect it. Whales may look smooth and hairless, but they do have hair, especially when they are young. Baby whales are born with tiny whisker-like hairs on their faces and lips called vibrissae. These hairs help newborns feel their way along their mother's body and locate the nipple for nursing. In species like humpbacks, you can sometimes see small hair follicles around the mouth, even in adults. These traces of hair are a leftover feature from their land-dwelling ancestors, which were fur-covered animals. As whales adapted to life in water, most of their hair disappeared because it created drag and slowed them down. But the nerves connected to those hair follicles are still active, suggesting they serve a sensory purpose. Some whale species even have a few hairs around the blowhole or jaw, hinting that whales are not as far from their furry, land-based relatives as they appear. Whale hearts beat only a few times a minute during deep dives. When a whale dives into deep water, its body enters a state of extreme energy conservation. One of the most dramatic changes occurs in the heart. A blue whale's heart, which may beat 10 to 30 times per minute at the surface, can slow to as few as 2 beats per minute during a deep dive. This slow heartbeat helps reduce oxygen use and preserves energy while the whale is hunting or exploring depths where pressure is immense. Blood flow is directed away from muscles that are not needed and toward vital organs like the brain and heart. This process is called the diving reflex, and it is far more powerful in whales than in humans or other mammals. When the whale returns to the surface, its heart rate rises rapidly again to circulate fresh oxygen through the body. This ability to change heart rhythm is one of the keys to surviving long, deep dives. Belugas can turn their heads in all directions. Most whales have stiff necks because their vertebrae are fused together, which prevents them from turning their heads independently of their bodies. Beluga whales are different. They have flexible necks with separate cervical vertebrae, allowing them to nod, tilt, and turn their heads in almost any direction. This unique feature makes belugas much more expressive and helps them navigate environments filled with ice, narrow channels, and shifting currents. Belugas are also famous for their facial expressions. Their rounded forehead, called a melon, is used for echolocation and can change shape slightly when they vocalize. The combination of head movement and vocal ability creates a level of expressiveness rarely seen in whales. Belugas use these movements in social interactions, hunting, and even in communicating with humans in captivity. Their extraordinary flexibility makes them one of the most adaptable and visually engaging species in the Arctic. Some whales can survive entirely without fresh water for their whole lives. Whales spend their entire lives in salt water and never drink fresh water directly, yet they need water to survive like any other mammal. They get all the water they need from the food they eat, such as fish, squid, or tiny crustaceans. When their bodies break down fat for energy, a chemical reaction creates water as a byproduct, a process called metabolic water production. Whale kidneys are also highly specialized. They can filter out excess salt from the bloodstream and produce concentrated urine, allowing whales to remain hydrated in an environment humans could not drink from. Even newborn calves get their water from milk, which is rich in fat and naturally low in salt. This extraordinary ability means that a whale can live for decades in the open ocean without ever needing a sip of fresh water from a river or lake. Whales use the Earth's magnetic field to navigate. Some whale species travel thousands of miles during migration, and they often return to the exact same breeding or feeding areas year after year. Scientists believe whales may use Earth's magnetic field as a kind of internal compass, Tiny particles of magnetite have been found in the brains of some marine mammals, which could help them detect the direction and strength of magnetic forces. This sensory ability would allow whales to orient themselves during long-distance travel, even when the ocean looks the same in every direction and the sun or stars are not visible. In rare cases where the magnetic field becomes disturbed, such as during solar storms, whales have been found to become disoriented and even strand themselves on beaches. While the exact mechanism is still being studied, the evidence strongly suggests that whales use a combination of sound, memory, and the planet's magnetic signals to navigate across entire oceans. Whales can get sunburned. Whales spend much of their time near the ocean's surface when they breathe, feed, rest, or socialize, and during those moments, their skin is exposed to direct sunlight. Just like humans, whales can experience sunburn from ultraviolet rays, especially in places where the ozone layer is thinner or the water is clearer and more reflective. Blue whales, fin whales, and sperm whales are particularly susceptible because they often bask near the surface for long periods. Scientists have documented blisters, peeling skin, and lesions on whales that appear similar to sunburn in humans. Darker-skinned whales seem to be more protected, while lighter-skinned individuals can become more vulnerable. It is believed that whales may produce their own version of melanin, which helps protect against UV radiation over time. This surprising vulnerability shows that even massive marine animals face challenges from changing environmental conditions, including increased sunlight and shifts in ocean depth and behavior. The blubber of whales can be more than 1 foot thick. Blubber is the thick layer of fat that surrounds a whale's body, and in some species it can grow thicker than 1 foot. This layer is essential for life in cold water, acting as both insulation and a reservoir of energy. Blubber allows whales to maintain a stable internal temperature even in icy environments like the Arctic, where water temperatures can drop well below freezing. It also helps shape the whale's streamlined body, reducing drag while swimming. During long migrations or fasting periods, whales rely on their blubber for fuel, breaking it down into energy and water. In addition to its thermal role, blubber offers buoyancy and protects internal organs from pressure during deep diving. Unlike ordinary fat, blubber contains a dense network of blood vessels that enable heat exchange. This biological adaptation allows whales to move between warm surface waters and cold depths without losing too much body heat or energy. Some whales can jump completely out of the water. Breaching is one of the most spectacular behaviors seen in the ocean, and certain whale species are capable of leaping their entire bodies out of the water. Humpback whales, in particular, are known for this dramatic display. They swim rapidly toward the surface, angle upward, and launch into the air before crashing back down with a thunderous splash. Scientists believe breaching may serve several purposes, including communication, dislodging parasites, or displaying strength during mating season. It may also help whales scan their surroundings quickly by giving them a brief visual look above the surface. Some species, like orcas and pilot whales, breach more frequently than others. Even blue whales, the largest animal on Earth, have been seen performing partial breaches, though their size makes full leaps rare. The fact that creatures weighing tens of thousands of pounds can leap into the air with such force is a stunning example of raw animal power. Whales can teach each other new tricks and behaviors. Whales do not just survive by instinct. They can learn from experience and even pass new behaviors to others in their group. One well-known example is a humpback whale technique called logtail feeding, where the whale slaps its tail on the surface before diving to trap fish. This behavior was first observed in just a few individuals, but within a few years, other whales in the same region began using the same strategy. Another case involved orcas that learned how to steal fish from commercial longlines. after watching a few innovative individuals do it successfully. These examples show that whales are capable of social learning, memory, and teaching. They do not rely solely on hardwired instincts, but instead benefit from shared knowledge, allowing them to adapt to new environments and challenges. Whales are not just smart, they are cultural animals, capable of change and tradition in a way few species are. Killer whales have cultural traditions passed down through generations. Orcas live in tight-knit family groups called pods, and each pod has its own unique behaviors, vocal patterns, and hunting techniques. These traditions are not genetically programmed, but learned through years of observation and practice. For example, some orca pods in the Pacific Northwest specialize in catching salmon, while others hunt seals or dolphins using entirely different tactics. In Argentina, a group of orcas has perfected the skill of intentional beaching, sliding onto shore briefly to grab seals before wriggling back into the water. This behavior is taught by mothers to their calves and is passed down through generations. Pods also communicate in distinct dialects made up of click and whistle patterns. These vocal traditions act like cultural signatures, allowing orcas to recognize family members even from a distance. No other marine predator is known to have such detailed and long-lasting cultural knowledge, making orcas a rare example of non-human cultural inheritance. Orcas use sophisticated hunting techniques based on the prey species. Orcas are apex predators, and their hunting strategies vary depending on what they are targeting. When hunting large whales, orcas work as a coordinated team, using distraction and exhaustion to separate calves from their mothers. When targeting fish, they may herd them into tight balls, then take turns rushing in to feed. In icy waters, orcas may create waves to knock seals off floating chunks of ice, a technique used only by certain groups that have learned this behavior. In tropical areas, some orcas use a method called carousel feeding, where they flash their white bellies to confuse schools of fish and make them easier to catch. The precision and variety of these techniques show a level of strategic thinking that goes far beyond instinct. Orcas are flexible, intelligent hunters who adapt to whatever food source is available in their environment, a key reason they are found in every ocean on Earth. Whales once walked on land before returning to the ocean. The earliest ancestors of whales were four-legged mammals that lived on land more than 50 million years ago. Fossils show that these animals, such as Pachycetus and Ambulocetus, looked like a mix between wolves and crocodiles. They had long snouts, sharp teeth, and strong legs for walking or wading in shallow water. Over millions of years, natural selection favored individuals that spent more time in water, where food was abundant and predators were fewer. Their bodies slowly changed. Legs transformed into flippers, noses migrated upward into blowholes, and their tails developed horizontal flukes for swimming. The bones of modern whales still contain traces of those ancient limbs, even though they are no longer visible on the outside. This transition from land to sea is one of the most dramatic evolutionary journeys ever discovered, and shows how flexible life can be when new opportunities arise. Whales have earwax rings that record their entire life history. Inside a whale's ear canal is a plug made of waxy material similar to earwax in humans, but much larger and denser. This plug grows in layers, forming visible rings that alternate between light and dark depending on the season. By counting these rings, scientists can determine the whale's age, much like counting tree rings. But the information does not stop there. These waxy layers also trap chemical signals from the whale's bloodstream, revealing details about its diet, stress levels, and exposure to pollution over time. For example, scientists have used earwax plugs to track spikes in stress during migration, breeding, or times of food shortage. They have also found traces of pesticides and industrial chemicals in certain layers, proving that some whales were exposed to harmful substances decades ago. Earwax is an unexpected but powerful record keeper, preserving a lifetime of information inside a single growing column. Sperm whales hunt giant squid in pitch-black ocean depths. Sperm whales are some of the deepest diving mammals on Earth, often plunging more than a mile below the surface to hunt for food. Their primary prey is the giant squid, an elusive creature rarely seen alive. Sperm whales use powerful echolocation clicks to scan for prey in total darkness, producing sounds so loud they can stun or disorient nearby animals. When they locate a squid, a silent battle unfolds in the dark. Scientists have found suction cup scars on the faces of sperm whales, evidence of squid tentacles fighting back with powerful grips. A single dive can last more than an hour before the whale must return to the surface to breathe. Despite the danger and difficulty of hunting at such depths, sperm whales rely heavily on squid for food, consuming hundreds of pounds per day. These deep-sea hunts are a reminder of how much of Earth's oceans remain unexplored and mysterious. Grey whales take one of the longest migrations of any animal. Every year, grey whales travel a round-trip distance of more than 10,000 miles between their summer feeding grounds in the Arctic and their winter breeding lagoons in Mexico. This journey is one of the longest known migrations of any mammal, and it requires enormous stamina and memory. Grey whales navigate through shallow waters along the continental shelf, using coastline features, ocean currents, and possibly Earth's magnetic field as guides. Along the way, they pass shipping lanes, predators, storms, and areas with little food. Pregnant females make the journey while carrying calves that will be born in warm, protected lagoons. After giving birth, they must swim all the way back to the Arctic while nursing their young. This long-distance migration helps grey whales avoid predators, find food, and raise their calves in safe waters, but it also makes them highly vulnerable to changes in climate, pollution, and human activity. A blue whale's call is one of the loudest sounds on Earth. A blue whale's call can reach nearly 200 decibels, making it louder than a jet engine at takeoff. Yet because the sounds are produced at extremely low frequencies, most of them are too deep for human ears to hear directly. These calls can travel for hundreds and possibly thousands of miles through the ocean's deep sound channels, which are layers of water where waves travel with very little loss of energy. Scientists believe that blue whales use these powerful calls not just to communicate with nearby whales, but to reach others that may be far over the horizon, in another part of the ocean entirely. During mating season, males can produce long, rhythmic pulse songs, repeating the same pattern for hours. These underwater broadcasts help blue whales locate one another across huge distances. Despite their size and volume, much is still unknown about the meaning and structure of these calls, which remain among the most mysterious forms of communication in the animal kingdom. Whales help fertilize the ocean with nutrient-rich waste. When whales release waste near the ocean surface, they are doing more than just relieving themselves. Their nutrient-rich feces contain high levels of nitrogen and iron, two resources that microscopic organisms called phytoplankton need to grow. Phytoplankton form the base of the marine food web and are responsible for producing more than half of the oxygen in Earth's atmosphere. In areas where whale numbers were once much higher, scientists believe the ocean was more productive overall because whale waste acted like a floating fertilizer. This natural fertilizer system is called the whale pump. Even whales that feed at great depths return to the surface to breathe and digest, bringing nutrients back with them. As whale populations slowly recover from past whaling, some areas of the ocean are showing signs of increased plankton growth. This suggests that restoring whales is not just good for biodiversity, but may also help fight climate change by increasing the ocean's ability to absorb carbon dioxide. Some whales can change the color of the water with their breath. When a whale exhales at the surface, it releases a mixture of air, water vapor, oils, and sometimes tiny particles from deep in the ocean. In some species, this exhaled mixture can appear as a cloud of color that briefly changes the water's appearance around them. Humpback whales, for example, release plumes that can leave a yellowish tint due to the presence of plankton, digested fish, or krill in their system. Certain baleen whales, like the fin whale, may even leave behind green or reddish tints that reflect the type of prey they have recently consumed. These color changes are temporary, lasting only for a few seconds, but they offer a visual clue about what the whale has been feeding on. Researchers studying whale behavior can sometimes infer diet and recent travel routes from the composition of these breath plumes, showing how even a single exhale can reveal hidden details about life beneath the bass. Surface. The eyes of whales have evolved for both sunlight and darkness. Whales have eyes that are uniquely adapted to handle two very different visual environments. At the surface, they must see in bright sunlight that reflects off waves and creates sharp glare. At depth, however, they encounter near total darkness, where only faint bioluminescent glows or reflected flashes can be detected. To deal with this, whales have evolved large spherical lenses and special cells in their retinas called Rob cells, which excel in low light. Their pupils can expand widely to take in more light at depth, and they are protected by thick, oily tears that prevent dehydration from saltwater exposure. Their vision is not as detailed as human vision, but it is extremely sensitive to motion and contrast, which helps them detect prey or predators in dim conditions. Some species may be able to see ultraviolet light, giving them an extra visual edge in murky or deep waters that would appear pitch black to us. Orcas in different regions speak different dialects. Orcas, or killer whales, use a complex system of clicks, whistles, and pulsed calls to communicate with one another. Each pod has its own dialect, made up of unique vocal patterns that are learned socially rather than genetically. These dialects can persist for generations, allowing scientists to identify specific groups and track their family trees based on sound alone. Orcas in the Pacific Northwest, for example, have very different vocal traditions from orcas in Antarctic waters. These differences are so distinct that even when two pods meet, they usually do not mix or interbreed if their dialects are too different. This suggests that sound is a key part of how orcas define family, territory, and identity. The diversity of orca dialects offers rare insight into animal culture, showing that some species do not just make noise, they speak in traditions handed down through generations. Whales can sleep while swimming. Whales never fully shut down their bodies the way humans do when they sleep. They must continue to surface to breathe, avoid predators, and stay aware of their surroundings. Many whale species have solved this problem by allowing only one half of their brain to sleep at a time, while the other half stays awake enough to control movement and breathing. In this state, whales can continue to swim slowly in gentle circles or drift near the surface while resting. Some, like pilot whales and sperm whales, form resting groups where they align themselves closely and move together as though floating in a shared dream. Their eyes may close, but their bodies never become totally motionless. This type of sleep, called unihemispheric slow-wave sleep, allows whales to survive in an environment where falling fully asleep could be deadly. Sleep for whales is not a shutdown, but a slow-motion drift between wakefulness and rest. Whales may dream, but we do not yet know for sure. Because whales sleep with only half their brain at a time, scientists are not certain whether they experience dreams the way humans and many land mammals do. In humans, vivid dreaming occurs during REM sleep, when the brain is highly active and the body is temporarily paralyzed. Whales do not appear to enter extended REM sleep, at least not in the way we do. However, parts of their sleep may still involve internal replay, or processing of experiences. Some researchers speculate that this could help whales learn new vocalizations, remember migration routes, or reinforce social bonds. Observations of calves sleeping near their mothers suggest that rest may even play a role in early learning and development. Without brainwave recordings from whales in the wild, the question remains open. It is possible that whales dream in ways we cannot easily detect, or that their minds rest in a form unlike any other mammal on Earth. Whale flippers have the same bone structure as human hands. If you were to look inside the flipper of a whale, you would find a set of bones arranged almost exactly like the bones in a human hand. There are wrist bones, palm bones, and finger bones, all fused and stretched to form a stiff paddle. These bones are a direct reminder of the whale's land-dwelling ancestors, whose legs and arms evolved over time into flippers used for steering and balance in the water. The shape and position of these bones give whales fine control over their movements, allowing them to make tight turns, stabilizing rolls or slow glides while hunting or playing. In humpback whales, the flippers are extra long and even have distinct knobs along the leading edge, which improve water flow and create lift like airplane wings. The hidden resemblance between whale flippers and human hands shows that evolution prefers to reshape existing structures rather than invent new ones from scratch. Scientists have recorded whales mourning their dead. Whales have been observed engaging in behavior that strongly resembles mourning. In several documented cases, mother whales have carried the bodies of their dead calves for days or even weeks, refusing to let them sink. Other whales have been seen nudging, circling, or vocalizing alongside dead pod members, as if trying to revive or comfort them. These observations have occurred across multiple species, including orcas, belugas, pilot whales, and sperm whales. While scientists cannot confirm whether whales feel grief in the same way humans do, these actions suggest a deep emotional response to loss. Some researchers believe that such behavior supports social bonds within whale families and may help individuals process separation. Mourning behavior in whales adds to the growing evidence that these animals have complex emotional lives, strong family attachments, and possibly an awareness of death that goes far beyond what was once assumed. Some whales sing duets, not solos. While many people know that humpback whales and other species sing long solo songs, scientists have discovered that some whales perform synchronized duets. In certain conditions, two whales will match their pitch patterns and rhythms almost perfectly, weaving their calls together into a single harmonious sequence. This duet behavior is thought to play a role in courtship, territory establishment, or coordination between individuals. In some cases, the whales alternate parts, taking turns in a call-and-response pattern, like a musical conversation. The complexity of these duets suggests a high level of auditory awareness and cooperation. It also shows that whale songs are not just instinctive noises, but shared expressions shaped by memory, learning, and interaction. These watery musical partnerships reveal how much more there is to understand about whale communication, and how much it may resemble the social and artistic expressions humans value in music. Only male humpbacks sing long, complex songs. In humpback whales, singing is not a shared behavior between the sexes. Only males produce the long, haunting songs that have become famous in ocean research. These songs can last up to 30 minutes and are made of repeating phrases, arranged into themes that shift slowly over time. The male may sing the same pattern for hours, sometimes while hanging motionless in the water, head pointed downward. The purpose of the singing is still debated. The leading theory is that the songs are part of courtship and sexual selection, used to attract females or compete indirectly with other males. Yet no one has ever seen a female visibly respond to a singer, leaving the mystery open. What is clear is that these songs are not random. They evolve from season to season, spreading through whale populations and even across ocean basins, like a cultural wave. The ability for a group of animals to learn and modify a shared musical structure is rare in nature, and among whales, it is a sign of intelligence, communication, and tradition. Whales can remember individual humans for years. There have been multiple recorded cases of whales recognizing and reacting to specific human individuals after long absences. In places where whales are cautiously approached or rescued from nets, they have been documented responding differently to familiar humans compared to strangers. Researchers studying orca and beluga whales in captivity have noted that whales can distinguish between people based on sight, voice, and even posture. They also remember how they were treated. A whale that had a positive experience with a diver may approach that person again later, while avoiding others. In the wild, some gray whales off the coast of Mexico have shown preference for particular boat operators, allowing certain people to approach and touch them gently, while ignoring other boats. Their memories appear to be highly selective, not just about danger or food, but also about social encounters. This level of long-term recognition implies that whales form mental maps of the world that include humans, suggesting emotional intelligence and a surprising depth of social memory. Baby humpbacks whisper to their mothers. When humpback whale calves are born, they stay close to their mothers for protection, warmth, and guidance. But they do something unexpected. They keep their voices quiet. Instead of broadcasting loud vocalizations like adult whales, young calves make soft grunts, squeaks, and murmurs that barely travel beyond a few meters. These whispers are thought to help them stay hidden from predators such as orcas and large sharks, which can detect sound from long distances. Scientists discovered this behavior using underwater microphones placed near mother calf pairs in migration channels. The whispered tones have a different acoustic signature than adult calls, almost like a secret language. This reduced volume also prevents other adult whales from detecting the calf and potentially interfering. Whispering is not just low sound. It is deliberate communication, adapted to survival during the most vulnerable stage of life. It shows that even newborn whales possess a built-in instinct for stealth and strategy in a vast ocean full of listening predators. Some whales migrate more than 10,000 miles every year. The gray whale holds the record for the longest known migration of any mammal, traveling a round-trip distance of more than 10,000 miles every year. But they are not the only whales on the move. Humpbacks travel from polar feeding areas to tropical breeding waters, often crossing entire ocean basins with remarkable precision. Blue whales have been tracked moving from cold, krill-rich waters in the Southern Ocean to the warm seas of equatorial regions. Migration requires immense endurance, memory, and navigation skills. Whales must time their journeys exactly right so that food is abundant when they arrive at feeding grounds and waters are calm and warm enough for calving in breeding areas. Many of these migrations take weeks or months without feeding, forcing whales to rely on stored fat deposits. These deep, ancient roots reveal connections between parts of the ocean that might otherwise seem unrelated, and they show how profoundly whales shape the living patterns of the seas. Whales can form long-lasting friendships. Whales are often social animals, and many species form stable relationships that can last for years. In dolphin-like whales, such as orcas and pilot whales, individuals travel with the same companions throughout most of their lives. These relationships are based not only on kinship, but on shared behavior, compatible personalities, and mutual protection. In humpbacks, researchers have observed pairs of whales meeting across many years during migrations, showing recognition and preference. Female sperm whales cluster into matriarchal families that raise calves together, defend against predators, and even adopt orphaned young. These enduring bonds allow whales to build social networks that support communication, learning, and survival. Friendships are not accidental. They are actively maintained through touch, synchronized movement, and shared calls. The emotional lives of whales are still being uncovered, but their ability to cooperate, play, mourn, and form attachments mirrors some of the deepest social patterns found in humans and other intelligent species. Some whales are born tail first to avoid drowning. Unlike most land mammals that are born head first, many whale calves enter the world tail first. This adaptation ensures that the baby's blowhole remains underwater until the final moment of birth, reducing the risk of premature breathing or inhalation of water. Once the calf is fully emerged, the mother helps guide it to the surface for its first breath of air, which must happen within minutes to prevent suffocation. Being born tail first also reduces the chance of the newborn becoming trapped inside the birth canal during delivery, since the tail is narrower and less likely to block the exit. This birth method shows extraordinary alignment between anatomy and environment. Every whale calf is born into a three-dimensional space where gravity, pressure, breath, and movement must be immediately coordinated. A single mistake can mean drowning. By emerging tail first, whale calves gain precious seconds to orient themselves and survive in a world that does not pause for adaptation. Whales have the most efficient breathing system on the planet. When whales surface to breathe, they exhale and inhale massive amounts of air in just a couple of seconds. Unlike humans, who typically exchange only a small portion of air in each breath, whales can replace up to 90% of the air in their lungs with every exhale and inhale cycle. This allows them to store oxygen with astonishing efficiency before diving. Their blood also contains unusually high levels of hemoglobin and myoglobin, proteins that store oxygen and release it gradually during long dives. Whales can collapse their lungs safely under high pressure to avoid air bubbles forming in blood vessels, preventing decompression sickness. When they return to the surface, a single pulse of breath replenishes most of their oxygen supply, minimizing both breathing time and exposure to predators. This optimized respiratory system allows some species to stay underwater for more than 2 hours without needing to surface. Whales can release heat through special veins in their flippers. Whales are warm-blooded animals and generate a significant amount of heat from swimming, feeding, and muscle activity. But in cold ocean waters, keeping the body at a constant temperature is essential. To regulate heat, whales use a system of countercurrent blood vessels called rhetia mirabilia, especially concentrated in their flippers, flukes, and dorsal fins. These vessels allow warm blood flowing from the body's core to transfer heat to cooler blood returning from exposed areas. When whales become too warm, they can increase blood flow through these regions, releasing excess heat into the surrounding water. This allows them to cool down without expending energy or surfacing. The flippers act like natural radiators, even though they lack blubber. This method of temperature control allows whales to move between warm surface waters and freezing depths, to migrate across seasons, and to maintain enough warmth during long periods of rest. Killer whales can live in both Arctic ice and tropical waters. Killer whales, or orcas, are one of the most widely distributed marine mammals in the world. They can be found in icy polar oceans, tropical seas, and everything in between. This adaptability comes from their flexible diet, advanced social behavior, and remarkable ability to regulate body temperature. In Arctic waters, orcas patrol ice edges, hunting seals and narwhals, while in tropical regions, they may target rays, fish, or even other whales. Their black and white coloration helps with camouflage in many environments, allowing them to blend into bright water when viewed from below and dark depths when seen from above. Different orca populations have developed unique cultural behaviors that allow them to survive in specific environments, rather than evolving into new species. The same animal that hunts penguins in Antarctica might have distant relatives that swim past coral reefs near Hawaii, showing just how adaptable and widespread the orca truly is. Some whales can swim more than 30 miles in a single hour. Certain species of whales are capable of explosive bursts of speed that rival some of the fastest animals in the ocean. Orcas and pilot whales can reach speeds of more than 30 miles per hour during a chase or escape. Even the much larger fin whale, the second largest animal on Earth, can travel at speeds over 20 miles per hour. These bursts of speed are powered by massive tail muscles and are aided by streamlined bodies that reduce drag. Speed helps whales catch fast-moving prey, evade predators, and travel efficiently over long distances when necessary. Unlike fish, which move their tails side to side, whales move theirs up and down, generating powerful thrusts that propel them forward. Their ability to cover entire ocean regions within days shows how effectively they are built for movement, not just size. Even young whales learn to swim fast within weeks of birth, ensuring they can keep up with the pod during migration. Whales have a built-in dive computer in their blood chemistry. Whales are able to perform deep, extended dives by regulating the chemistry of their blood in ways that no land animal can match. Before a dive, their blood is rich with oxygen stored not only in the lungs but in high concentrations within their tissues, muscles, and bloodstream. Unlike humans, whales can naturally tolerate high levels of carbon dioxide and lactic acid, which build up during long periods without oxygen. Specialized proteins like myoglobin store oxygen directly inside muscle fibers, giving whales a powerful reserve during deep descents. Their blood vessels constrict in non-essential areas such as the skin and extremities during a dive, redirecting oxygen-rich blood to vital organs like the heart and brain. Whales are also able to slow their heart rate dramatically, reducing oxygen use and keeping energy demand low. This internal regulation acts like a precise automatic dive computer, monitoring depth, oxygen levels, and even temperature changes. No buttons, no screens, just an instinctive, finely tuned biological system that evolved over millions of years to allow whales to descend thousands of feet into crushing pressure and return safely to the surface again. Whale baleen was once used to make corsets and umbrellas. Baleen is the flexible, comb-like material that some whales use to filter tiny prey, like krill, from seawater. It is made of keratin, the same protein that forms human hair and nails, but it is far stronger and more resilient. Before plastic and steel were developed, baleen was prized in human manufacturing because it was lightweight, tough, and springy. In the 1800s, it was used to create the stiff ribbing in corsets, hoop skirts, and collars. It also formed the ribs of umbrellas, the frames of early carriage tops, and even the bristles of whips and brushes. People called it whalebone, even though it was not bone at all. By the time commercial whaling peaked, the demand for baleen had reached global levels. Factories lined waterfronts in America and Europe, boiling and processing it for fashion and industry. It took the invention of cheaper synthetic materials and rising conservation awareness to end the era of baleen use. Today, baleen remains a symbol of a time when whale products were woven into everyday life, and when the life of whales was balanced against the demands of human style and invention. Whales are still evolving today. It might be tempting to think that whales, having reached such impressive size and specialization, are finished evolving. But evolution never stops. Modern whales continue to adapt to changing oceans, shifting food supplies, and threats brought on by climate change and human activity. Scientists studying whale DNA have found signs of ongoing selection in genes related to immunity, metabolism, and sensory development. For example, some populations of killer whales are evolving to specializing new food sources as fish populations decline. Certain fin whales show evidence of changes in hearing sensitivity, possibly a response to noisy oceans filled with ship engines and sonar. Even body size is shifting. In areas with less food, whale calves may be born smaller, better suited to surviving long migrations with fewer resources. Evolution does not always mean dramatic change. Sometimes it is a subtle shift in behavior, anatomy, or physiology passed down to the next generation. The whales of tomorrow will not be identical to the whales of today. They are still on an evolutionary journey, shaped not only by nature, but by the impact we humans impose on their world. Some whales sing in frequencies humans cannot hear. Whale songs often seem hauntingly familiar because they fall in the same frequency range as human speech. But some whales, particularly blue whales and fin whales, rely on vocal frequencies so deep that humans cannot hear them without special equipment. These infrasonic sounds can travel through dense seawater for hundreds of miles, potentially connecting populations across entire ocean basins. A blue whale might sing at a frequency below 10 Hz, far below the threshold of human hearing. These low frequencies are perfect for long-distance communication because they lose very little energy over time. Scientists believe whales may use these calls to locate mates, coordinate migration, or maintain social awareness in murky, lightless depths. The ocean is full of sound we rarely notice, and whales may be speaking in ways we have only begun to understand. Every year, new underwater listening stations reveal hidden choruses of songs that have echoed for centuries, always present, but just beyond human reach. Blue whales eat nearly 4 tons of krill every day. A fully grown blue whale consumes more food in a single day than most animals eat in a month. During feeding season, a blue whale will eat up to 4 tons of krill every 24 hours. That is roughly equal to 80 million rice-sized crustaceans a day. To fuel this appetite, the whale lunges into clouds of krill with its mouth wide open, expanding its throat like a parachute and taking in more water than its entire body volume. It then closes its mouth and pushes the water out through baleen plates, trapping the krill inside and swallowing them in huge gulps. Even young blue whales need a massive diet to fuel their rapid growth. They gain more than 200 pounds every day while nursing and require gallons of milk rich in fat just to stay alive. The sheer scale of their appetite makes blue whales one of the most influential species in the food web, redistributing nutrients and shaping entire marine ecosystems wherever they feed. Some whales have scars from battles with giant squid. Deep-sea squid are elusive animals, rarely seen alive, but they leave marks behind. Sperm whales, which dive deep into the ocean to hunt giant squid, often return to the surface with circular scars on their heads and faces. These marks match the size and shape of suction cups found on the tentacles of giant squid. As the whale attempts to overpower and swallow the squid fights back with sharp beaks and grasping arms, leaving behind evidence of fierce underwater battles. Large male sperm whales, which dive deeper and hunt more frequently than females, often have the most scars. These scars are so consistent across individuals that they serve almost like a badge of survival in the deep. Giant squid are powerful enough to grow more than 40 feet long, yet sperm whales still dominate as hunters in the abyss. The existence of these scars gives us a rare window into a world we barely understand, where battles between massive predators unfold in total darkness. The skeleton of a whale can support entire forests of deep-sea life. When a whale dies and sinks to the seafloor, its enormous body becomes a foundation for a rich and lasting ecosystem known as a whale fall. The carcass supplies food and shelter for dozens, sometimes hundreds of species that live in the deep, where food is scarce. Scavengers such as hagfish and sleeper sharks arrive first, stripping away soft tissue. Then, smaller organisms begin feeding on leftover fat, skin, and bone. Over time, specialized bacteria break down the whale bones themselves, releasing nutrients like sulfide that fuel entire communities of worms, snails, and clams. These ecosystems can last for 50 years or more, forming a miniature world in the darkness. Some species found only on whale falls have never been seen anywhere else, suggesting that whales shape biodiversity long after their lives have ended. A whale fall is not just a death. It is a transformation, turning a single body into a deep-sea forest buzzing with strange, resilient life. Whales use bubble curtains to confuse fish. Some whales have developed an ingenious hunting technique using bubbles rather than teeth or speed. Humpback whales, for example, blow rings or curtains of bubbles around schools of fish, creating a net of shimmering air that panics the prey and forces them into a tight cluster. Once the fish are trapped in this bubble cage, the whales will swim upward through the center with their mouths open, swallowing thousands of fish in a single lunge. This strategy, called bubble net feeding, is not instinctive. It is learned and often coordinated among multiple whales, each playing a specific role. One whale may circle while others dive or create sound to herd the fish more tightly. The cooperative nature of bubble net feeding shows how whales can adapt and invent new feeding methods, passing them along to younger generations like a shared craft. These bubbles are not just air. They are tools, formed and used with precision, strategy, and teamwork. Some whales have kneecap bones left over from their land ancestors. Deep within the bodies of some modern whales are tiny bones that no longer serve a purpose, but reveal a hidden past. These include vestigial kneecap bones, remnants from the time when whale ancestors lived on land and walked on four legs. Though whales no longer have hind limbs on the outside, these small internal bones are evidence of their ancestry. They reflect a time more than 50 million years ago when the earliest whales resembled small, hoofed mammals that hunted along riverbanks. Over time, their legs transformed into flippers, their bodies grew streamlined, and their hips shrank until they were almost invisible. Yet evolution does not always erase old structures right away. These leftover bones have no current function, but their presence proves that whales are not just creatures of the sea. They are also creatures of the past, carrying fragments of their history inside them, like fossils wrapped in living tissue. Whales can see in ultra-low light thanks to eye adaptations. When whales dive into deep water, they enter a world where sunlight disappears completely after just a few hundred feet. To survive and hunt in darkness, whales have eyes specially adapted for low-light vision. Their retinas are packed with rod cells, which are more sensitive to faint light than the cone cells used in daytime vision. Many whales also have a reflective layer behind the retina called the tapetum lucidum, which helps them use every available photon by bouncing light back through the eye twice. Their pupils can widen dramatically to draw in more light, and their eyeballs are spherical, allowing clear focus in both bright surface light and deep ocean blackness. These adaptations do not allow whales to see color well, but they allow them to detect movement and shapes with exceptional clarity in near darkness. Being able to see in almost no light is not just useful, it is essential for survival in the deep. Every whale has a unique tail print, like a fingerprint. The underside of a whale's tail, known as the fluke, contains a pattern that is specific to every single individual. These patterns consist of scars, pigmentation marks, notches, and natural scratches that develop throughout a whale's life. No two fluke markings are the same, even among calves born to the same mother. Scientists use high-resolution photographs of whale flukes to identify and track individuals across oceans. This practice has allowed researchers to build long-term histories of certain whales, revealing migration routes, breeding habits, and even shifts in population over decades. Some whales have been photographed over 30 years apart, allowing experts to witness their full lives through these visual records. Whale tail identification is non-invasive and has been a vital tool in conservation research. These tail prints show the story of a whale's life, much like the lines on a human hand can reflect a lifetime of experience. They are natural signatures, visible only when the whale dives deep and lifts its tail to the sky. Whales may know the shape of the seafloor better than we do. Whales navigate with such precision that scientists believe they may carry mental maps of the ocean floor. Modern sonar and satellite imaging still leave gaps in our knowledge of the underwater landscape. But certain whale species, including grey whales and humpbacks, return to the same underwater valleys, ridges and canyons year after year, even through rough currents and low visibility. They appear to navigate using a combination of memory, magnetism, and sound. Whales can detect changes in water pressure, current direction, and even how sound reflects off underwater rock formations. This allows them to sense the shape of the world beneath them without needing to see it directly. Some migration routes follow underwater mountain chains or ancient sea paths that once guided whale ancestors. These routes do not depend on landmarks visible from the surface. They are written into the ocean itself. If whales do carry mental maps of the seafloor, they may know parts of our planet more intimately than we do. Orcas can teach each other to hunt sharks. Orcas are not just powerful predators. They are cultural animals who pass down knowledge through generations. In certain parts of the world, orcas have developed a technique for hunting sharks that involves flipping the shark upside down to induce a state called tonic immobility. When this happens, the shark becomes paralyzed, giving the orca time to remove the shark's liver, which is rich in energy. Young orcas do not learn this behavior by instinct. They learn it by watching their elders. This method has been seen spreading between family pods, showing that orcas share strategies and learn from one another in ways similar to human teaching. The fact that an animal can observe, practice, and improve a hunting technique reveals a remarkable form of intelligence. It also shows how orca culture can change depending on what food is available in their environment. When prey becomes scarce, the community adapts, and knowledge spreads like a living inheritance. There are whale species we have only just discovered. Even today, new whale species are still being identified. In recent years, researchers confirmed the existence of the Rice's whale, a distinct species living in the Gulf of Mexico. It had been mistaken for another species until DNA analysis revealed otherwise. Other species are even more mysterious. Some have only been detected through deep water recordings of unfamiliar whale songs. These vocalizations do not match any known whale species and may belong to animals that rarely surface near ships or coastlines. In remote parts of the Pacific Ocean, scientists have found skulls and bones belonging to whales that do not match any catalogued species. The fact that such large mammals can remain unknown to science shows how vast and unexplored the ocean remains. There is a very real possibility that whale species still swim under our radar, living out their lives in deep water regions we have yet to explore. Whales can recognize their own songs echoing across oceans. Whale songs are more than just communication tools. In certain waters, sound can travel such long distances that whales may hear the echoes of their own songs reflecting off underwater land formations. Research suggests that whales can recognize these echoes, allowing them to make sense of their surroundings through sound alone. This is similar to how bats use echolocation but on a planetary scale. A whale may release a long, low-frequency call and then listen to how it returns from physical features miles away. This helps them gauge distance, depth, and position, even in darkness. Whale songs do not just reach other whales. They shape how whales perceive space, allowing them to build something like a mental map made of sound. The idea that a whale can hear its own voice return from hundreds of miles away is a reminder of how sensory life changes in the ocean, where sight becomes secondary and sound becomes vital. Humpbacks can coordinate attacks without making a sound. Humpback whales are known for their intricate group hunting techniques, especially bubble net feeding. But researchers have observed other forms of hunting where humpbacks work together in silence. Instead of vocalizing, they use movement, timing, and body orientation to corral prey into a tight formation. One whale may swim in a broad arc, while another rises from below, forcing fish to compact into a dense mass. Other whales may hover in coordination, waiting for the exact moment to strike. Each whale seems to know where the others are without sound or visual cues. This suggests that whales may be able to sense pressure changes or subtle vibrations in the water to stay aligned. Their cooperation is so precise that it resembles a team sport played in 3 dimensions, guided by an unspoken rhythm. This silent coordination challenges assumptions about how animals communicate and shows that whales are capable of teamwork even when their voices are quiet. Some whales fast for months during migration. Many whale species undertake long migrations between feeding grounds and breeding grounds. During these journeys, they often do not eat at all, relying instead on stored fat reserves called blubber. A grey whale may eat constantly during summer months in the Arctic, building thick blubber layers before swimming more than 5,000 miles south to warm breeding waters. During this migration, the whale will not feed, metabolizing stored fat for energy, water, and body temperature regulation. The same is true for humpbacks, which may fast for more than 4 months. This ability to survive long periods without food requires tremendous efficiency in energy use. It is not just a matter of endurance. It is a biological strategy supported by dense, slow-burning fat that provides everything the whale needs until it reaches waters rich in prey once again. These long fasts show how migration is not just movement, but a calculated balance of risk, biology, and timing. Whale larynxes are so large they could fit a human inside. The largest whales on Earth have larynxes so massive that a full-grown person could fit inside them. These throat structures are what allow whales to create their extraordinary calls, some of which are powerful enough to travel across an entire ocean basin. Unlike humans, who use vocal cords that vibrate rapidly to create sound, whales use folds of tissue inside the larynx and muscular chambers that push air through with astonishing force. Their voices do not depend on exhaling into open air. They recycle air within the body, allowing them to sing underwater without losing buoyancy or energy. The sheer scale of these organs is matched by their sensitivity. A blue whale can control pitch, volume, and rhythm with precision, shaping sound the way a human might shed breath through a flute. These giant instruments are part of their identity and a core part of how they connect, court, defend, and explore. The skin of whales can peel and regrow in giant sheets. Whales live in salt water that can erode and irritate skin, so they replace it regularly in large, visible sheets. Unlike humans, who shed tiny skin cells constantly, some whales release whole layers of expired skin at once. Beluga whales are known to migrate into shallow river estuaries during summer, where they rub along gravel beds to remove old skin. Other whales simply allow the motion of the sea to lift away dead layers while they swim. Fresh skin not only reduces the risk of infection, but also keeps the whale hydrodynamic by minimizing drag. Shedding also helps remove parasites and bacteria that cling to the outer surface. A healthy whale can renew its skin several times a year without ever stopping to rest. The process is seamless, silent, and essential for survival in a world full of salt, sunlight, and constant motion. Whales are built to survive in water colder than ice. Arctic and Antarctic waters can drop below the freezing point of fresh water, yet whales move through them with ease. Their blubber layer, which can be more than 1 foot thick in large species, acts as insulation that blocks internal heat from escaping. Beneath the blubber, whales have dense networks of arteries and veins that exchange heat efficiently, allowing warm blood to heat cooler blood returning from the flipper's tail or skin surface. Their skin contains no sweat glands, which prevents heat loss through evaporation. Even their heart rate slows in freezing water, conserving oxygen and energy. These adaptations allow whales to swim through water that would freeze human flesh within minutes. They are not just surviving in the cold. They are shaped by it, adapted through millions of years to turn a deadly environment into a natural realm of migration, feeding, and life. Some whales carry entire ecosystems on their skin. Some whales carry entire ecosystems on their skin. These ecosystems consist of barnacles, algae, diatoms, copepods, and other organisms that attach themselves to the whale's body and live there for months or even years. Up close, scientists have found more than 100 different species inhabiting the skin of a single humpback whale. The barnacles that cling to the whale's skin grow sharp ridges that slice through water and create small hiding places for even smaller organisms like amphipods and sea lice. A whale covered in barnacles and algae can appear mottled green, brown, white, or black, depending on the environment it has recently visited. These hitchhiking species ride ocean currents without effort and are transported across thousands of miles each year, spreading genetic diversity as the whale moves. They provide insights into changing ocean temperatures, plankton levels, and migration seasons based on the composition and color of the community. In return, the whale gains nothing but added drag, yet the ocean gains an entire traveling habitat in motion that links otherwise isolated parts of the sea. The eyes of whales communicate emotion through shape and movement. The eyes of whales communicate emotion through shape and movement. Although whales do not have eyebrows or expressive faces like humans, they convey signals through subtle changes in eye shape, lid angle, and motion. When a whale is calm, its eye often appears wide and relaxed. When threatened or alert, the eye may narrow or dart quickly. Mother whales frequently maintain eye contact with calves, a behavior that has been interpreted as nurturing. In captivity, some species are known to make direct eye contact with humans for extended periods, leading many researchers to believe that whales use eye behavior as part of their emotional communication. Toolkit. The muscles surrounding the eye are strong and precise, allowing whales to rotate their gaze even when their heads remain still. Their eyes are capable of resisting high pressure in deep water, yet remain sensitive enough to detect emotion in other whales at close range. These cues play an important role in bonding, parenting, and maintaining social structure within pods, especially in low light or murky water where voice alone is not enough. Whales can hear sounds from hundreds of miles away. Whales can hear sounds from hundreds of miles away. The ocean is an efficient conductor of sound, and whales have hearing systems specially adapted to detect vibrations from vast distances. Baleen whales such as blue, fin, and humpback whales can pick up low-frequency calls from other whales far beyond the range of human hearing. These infrasonic sounds travel through the deep sound channel in the ocean, a natural layer of water that allows waves to move with little energy loss. A single whale call may circle an entire ocean basin and reach others who are out of sight. This powerful hearing ability allows whales to locate mates, avoid danger, and navigate underwater landscapes that they cannot see. Toothed whales like dolphins and orcas use high-frequency echolocation clicks to detect objects and hunt with pinpoint accuracy. Their skulls are specialized to focus and receive sound, acting like built-in acoustic mirrors. Whale hearing is not just an adaptation. It is a form of spatial intelligence that replaces vision in a world of darkness and distance. Orcas can flip ice floes to knock seals into the water. Orcas can flip ice floes to knock seals into the water. In polar regions, orcas work together to target seals resting on sheets of floating ice. The whales swim in formation, creating waves that push the ice floe higher or tilt it to one side. When the moment is right, the pod coordinates a final surge that flips the ice completely, sending the seal sliding into the water where the orcas are waiting. This hunting method requires teamwork, strength, and perfect timing. Young orcas learn the strategy by watching older members of the pod, demonstrating a form of cultural transmission. This behavior has been documented in multiple locations, including Antarctica, where orcas perform the maneuver with such precision that it appears rehearsed. Each member of the pod has a role, from wave generation to positioning. These cooperative hunts reveal an advanced level of planning and communication, proving that orcas are not just hunters, but tactical problem solvers. Whales can consume food equivalent to their body weight in a few weeks. Whales can consume food equivalent to their body weight in a few weeks. Blue whales, the largest animals on Earth, can eat up to 4 tons of krill every day during peak feeding season. This intense feeding period lasts only a few months, but provides enough energy to fuel migration, reproduction, and fasting through seasons where food is scarce. Humpback whales bulk up on krill and small fish in polar waters, packing on layers of blubber that store calories, water, and insulation. Even young whales gain hundreds of pounds each day while nursing, requiring gallons of nutrient-rich milk from their mothers. The ability to consume so much food in so little time is a vital adaptation. It allows whales to travel enormous distances and survive long stretches without eating at all. This extreme feast and famine cycle plays a major role in shaping whale behavior and physiology, as well as impacting the ocean ecosystem through nutrient redistribution. Whales have invisible tattoos made of scar tissue. Whales have invisible tattoos made of scar tissue. Every scratch, bite, scrape, and healed wound leaves behind a mark that changes the texture and color of the whale's skin. These scars can come from playful contact with other whales, interactions with predators like sharks and orcas, or encounters with fishing gear and ship hulls. Some whales develop patterns of white or gray scarring that form streaks and patches unique to that individual, allowing scientists to identify them from photographs. These markings may be hidden beneath algae, barnacles, or loose skin, but they remain for life, recording a history of survival. Scar patterns have helped researchers track aggression, social behavior, and even traumatic events across whale populations. The skin of a whale is a living record, inscribed not with ink, but with time and experience. Whales can go months without drinking any water. Whales can go months without drinking any water. Unlike land mammals, whales do not drink seawater because it would dehydrate them. Instead, they get all the water they need from the food they eat and the fat they metabolize. Krill, squid, plankton, and fish all contain moisture that becomes available when digested. When whales burn fat during long migrations, a chemical process inside their bodies converts fat into energy and water. This metabolic water is pure and free of salt, allowing whales to stay hydrated even in the middle of the ocean, where fresh water does not exist. Some whales migrate for months without feeding or drinking, relying entirely on stored resources. This water conservation system is so efficient that whales never need to surface to find fresh water. Their bodies are fully adapted to a world where drinking never happens, and hydration happens inside every cell. Whales can swim backwards and turn on the spot. Whales can swim backwards and turn on the spot. While most large animals have limited movement in tight spaces, whales are surprisingly agile for their size. They use the powerful muscles in their flippers and tail to control movement not just forward, but in reverse and even rotationally. Beluga whales are especially known for their ability to maneuver with precision, bending their necks and flexing their bodies in ways other whales cannot. Orcas and pilot whales can rotate in mid-water, changing direction in just a few strokes. Humpbacks use the long edges of their pectoral fins like rudders, steering with subtle adjustments. These abilities help whales navigate narrow caves, ice channels, and complex seafloor landscapes. Swimming backwards may also help whales during interactions with calves, feeding events, or delicate moments near the surface. They are not just giant swimmers. They are fluid movers in a three-dimensional space. Scientists have found whale bones hundreds of miles inland. Scientists have found whale bones hundreds of miles inland. These discoveries are not from beached whales carried inland by people or floods. They are ancient fossils, showing that parts of the land we now walk on were once covered by ocean. In deserts such as the Sahara, entire skeletons of early whales have been found surrounded by rock formations that formed underwater. These fossils belong to ancestors of modern whales that still had legs, hooves, and long skulls that resemble wolves more than dolphins. Other fossil beds in Chile and Peru have revealed mass whale strandings from millions of years ago, long before humans existed. The presence of these bones helps scientists understand how Earth has changed, how oceans have risen and fallen, and how whales adapted from walking on land to swimming in the sea. Whale bones on land are reminders that the story of the ocean is written across continents and time. Whales once swam in rivers that no longer exist. Whales once swam in rivers that no longer exist. Early whale ancestors lived in shallow coastal streams, estuaries, and even freshwater rivers before they fully adapted to the sea. Fossil evidence shows that species such as Ambulocetus, which lived more than 40 million years ago, swam like an otter and hunted in water, but still had working legs for walking on land. Over millions of years, these animals shifted from river dwellers to ocean giants. But even millions of years later, some whales still enter rivers. Belugas swim deep into Arctic estuaries during summer. Grey whales have been found in narrow waterways thousands of miles from the sea. These behaviors are fragments of an ancient legacy. Modern whales carry bone structures, behaviors, and instincts that link them to a world long vanished. They are ocean giants who were once river hunters, and their evolution tells a story of worlds lost beneath rock, sand, and time. Whales can abandon songs they have sung for years to adopt new ones. Whales can abandon songs they have sung for years to adopt new ones. This astonishing behavior has been observed most clearly in humpback whales, which sing long, complex sequences of notes that change over time. Entire populations of males can suddenly drop the songs they have been repeating for months and replace them with entirely new ones, often imported from distant groups of whales. This cultural replacement can spread across thousands of miles, with one song being replaced by another in what scientists call a vocal revolution. The process resembles the way humans adopt new music trends, where older styles fade and new forms take hold across regions. These whales do not mix or migrate with one another, but their songs travel through shared waters and gatherings, carried by sound alone. This ability shows that whales not only learn, they choose, update, and reinvent their cultural traditions. What makes this even more remarkable is that no other animal on Earth is known to replace learned vocalizations on a population level except humans. Belugas are called canaries of the sea for their vast vocal range. Belugas are called canaries of the sea for their vast vocal range. These small, pale whales produce an astonishing variety of sounds, including chirps, whistles, clicks, trills, and even tones that resemble human speech. While most whales focus their sound production in one or two frequency ranges, belugas can vocalize across a wide spectrum, making them some of the most versatile communicators in the ocean. They use sound to navigate, hunt, socialize, and maintain contact in murky Arctic waters where visibility is low. Beluga calves learn vocal patterns from their mothers and other group members, creating vocal cultures that vary between pods. Some belugas in captivity have even been known to imitate the rhythm of human voices or mimic environmental noises, showing an ability to adapt sound for social connection. Their vocal flexibility suggests high intelligence and social engagement, and their constant chatter creates underwater soundscapes as alive and layered as a rainforest. Grey whales can roll in mud to remove parasites. Grey whales can roll in mud to remove parasites. They migrate through shallow coastal lagoons during breeding season, where they rub their massive bodies along sandy or muddy sea floors to scrape off barnacles and skin parasites that have attached themselves during long feeding months in the Arctic. This self-grooming behavior churns up sediment clouds visible from shore, creating swirling brown trails that mark the whale's slow rotation through the water. Researchers have identified specific regions on the whale's bodies where parasite buildup is heaviest, especially near the tail, fins, and head. These exfoliation rituals help the whales shed dead skin, relieve itching, and renew their outer layers before returning to deep, open waters. The behavior also leaves telltale markings on whale skin, which scientists use to identify individuals and track parasite load. Grey whales are one of the few marine mammals known to use the environment itself as a grooming tool, turning the ocean floor into a natural scrub brush. The whales of ancient oceans once had feet and fur. The whales of ancient oceans once had feet and fur. More than 50 million years ago, the ancestors of modern whales resembled wolf-sized land mammals with hooves, sharp teeth, and dense coats. One of the earliest known species, called Pachycetus, lived along riverbanks and hunted in shallow water, but still walked on land. Over millions of years, its descendants evolved into creatures like Ambulocetus, which could swim like an otter but still had functional legs. Gradually, their bodies became more streamlined. Their nostrils moved to the top of the head to form blowholes, and their hind limbs shrank into useless nubs hidden beneath the skin. Fur was replaced by thick layers of blubber for insulation in deeper water. The fossil record shows that whales did not leap from land to sea in one step, but transitioned through dozens of intermediate forms that reveal the transformation of bone, muscle, and sensory systems. Today's whales carry tiny vestigial bones inside their bodies as reminders of their furred and footed beginnings. Sperm whales can use sound to stun their prey. Sperm whales can use sound to stun their prey. They produce some of the most powerful biological sounds on Earth, generating intense clicks from a specialized organ in their massive heads called the spermaceti organ. These clicks are focused into narrow beams that act like acoustic bullets. While the exact mechanism is still debated, there is evidence that the sound waves can temporarily disorient or immobilize squid and fish in deep water, making them easier to catch. Sperm whales dive to depths greater than 1 mile where sunlight does not reach, relying almost entirely on sound to hunt in total darkness. Their clicks can reach levels of more than 200 decibels, louder than a jet engine, though tightly directed and rarely heard on the ocean surface. This acoustic hunting strategy allows sperm whales to locate, track and capture giant squid and other fast-moving prey in the black, pressure-filled depths of the sea. Whales can recognize distinctive whale-watching boats. In places where human visitors regularly approach whales, certain individuals have been observed showing preference for specific vessels and avoiding others. Researchers in Baja California report that some gray whales approach familiar boats and allow people to touch them, while ignoring or even fleeing from boats they do not recognize. This recognition appears to be based on sight, sound, and engine frequency. Whales learn to associate certain vessels with safe behavior and others with danger or disturbance. This selective approach suggests long-term memory and the ability to distinguish subtle variations in shape and noise. Such behavior challenges the assumption that whales see humans as identical. Instead, they appear to form impressions based on repeated encounters, storing information that may last across seasons. These responses are not guaranteed. They are earned through consistent respect and gentle approach by humans who enter the whale's world. The first whales appeared more than 50 million years ago. They evolved from small, hoofed mammals after the extinction of the dinosaurs, during a time when Earth's climate was warm and shallow seas spread across continents. These early proto-whales, known collectively as Archaeocetes, went through dramatic transformations as they adapted to aquatic life. Their noses slid backward, their limbs flattened, and their spines elongated for efficient swimming. Fossils found in Pakistan and India show how each stage of evolution added a new aquatic skill while retaining traces of terrestrial anatomy. Over time, whales diversified into two main branches: toothed whales that used echolocation to hunt, and baleen whales that fed by filtering vast amounts of water. This branching marked one of the most profound evolutionary experiments in mammalian history, resulting in creatures that left the land behind and mastered a world of depth, pressure, and sound. Killer whales can imitate the behavior of other whale species. They are highly observant animals that learn not only through experience, but by watching the actions of others. Some orca populations have been seen adopting hunting techniques used by dolphins, humpbacks, or other ocean predators when such behavior proves useful. For instance, in certain areas, orcas have copied the tail-slapping strategies of humpbacks to stun schools of fish. In other regions, they have learned to mimic the vocal patterns of unrelated species to lure them closer. This imitation shows that orcas do not rely solely on instinct or inherited behavior. They adjust their strategies based on opportunity and social learning. This behavioral flexibility is one reason orcas are found in diverse environments, from polar ice fields to tropical reefs. They behave less like preset creatures and more like adaptive thinkers able to borrow and refine ideas from the world around them. Whales create underwater sound maps to navigate. They live in a world where light fades quickly, but sound travels far. By releasing pulses, calls, and clicks into the water, whales gather information about distance, object density, and seafloor features based on how the sound waves return. Toothed whales, such as dolphins and sperm whales, use echolocation to build precise mental images of their surroundings, even in complete darkness. Baleen whales, which do not use echolocation, rely on low-frequency songs that bounce across underwater landscapes, giving them long-range awareness of obstacles and open pathways. Scientists believe whales can detect subtle changes in how sound reverberates, creating internal maps of trenches, canyons, and coastlines. These maps are not visual but acoustic, formed by memory and repeated use. They allow whales to return to the same breeding grounds and feeding sites year after year, even after thousands of miles of migration. Whales may have emotional lives as deep as their ocean homes. Whales may have emotional lives as deep as their ocean homes. Evidence from field observations, brain anatomy, and social behavior suggests that whales experience complex emotions including grief, joy, curiosity, and empathy. Large whale species have limbic systems similar in structure to those of humans and great apes, areas of the brain associated with emotion and memory. Orcas and sperm whales have been seen mourning dead relatives, carrying their bodies for days, or staying by their side in silence. Humpbacks have interfered in attacks by predators to protect other species entirely unrelated to them, behavior that appears to have no direct survival benefit. Whale calves play and explore like young humans, learning through experience and forming attachments. These signs point to a depth of inner life that goes far beyond instinct. The ocean may be their physical world, but their emotional world appears vast, layered, and deeply connected to others around them. From the quiet pulse of the deep to the songs that travel beyond the reach of light, we have drifted alongside giants who carry entire ecosystems on their skin and entire histories in their bones. It is easy to forget, in the rhythm of ordinary days, that we share this planet with beings who speak in sound, feel in currents, and remember in songs older than our lifetimes. If you enjoyed this peaceful journey into the living blue, I invite you to like, subscribe, or share a thought below. It truly helps this little corner of calm reach the next wandering mind, someone out there who might need a quiet place to rest. But for now, just breathe. Let your thoughts float like sunlight on gentle water. Let your eyes soften. And let yourself drift slowly into sleep, knowing that the ocean above and below is still alive with quiet wonders. Good night.